Hello, dear students. My name is Francesco Tamagnini, and today I will talk to you about kidneys, one of my favorite topics, because it has to do more with the brain than you would think, because there's a whole exchange of ions and fluids. It's very similar to what happens in neurons and in brain to a point. But without further ado, I will enter into this one of three course. Each lecture has been divided in three, in blocks of more or less 20 minutes, which you can find on stream on which you presumably are looking at right now. So in the first lecture, which is the one of today, we will give an overview on the structure and the function of the kidney, pretty straightforward. While in lecture number two, we will talk about the regulation of electrolytes and water balance. While in lecture number three, we will focus on the regulation of the pH of body fluids. So take it easy. It's a complex system with many moving parts and some difficult concepts. It's also very fascinating because it's part of the larger system, which is the organism. And you will hopefully see how the specific functions of the kidneys relate with the different homeostatic systems of our beautiful organism. So at the end of these lectures, you should be able to understand the structure of the kidney and how the renal blood circulation work and what a nephron is and how it works. Understand more or less the basic functions of the kidney and the renal system. And most specifically, you should be able to describe what glomerular filtration is, what renal clearance is, and what secretion and reabsorption within the context of the kidneys are. So the plan of today's lecture is to give you an introduction on the renal system. We will then talk about the structure of the kidney. And then we will talk about the elaboration of urine with the three sub-processes of filtration, secretion, and reabsorption. And finally, we will talk about renal clearance. The textbook of medical physiology by Guyton Hall is a very complete textbook if you want to reconfirm whatever you find in this lecture and maybe to go a little bit deeper if you're interested to have further information about the kidneys and their function. So kidneys are actually very common in our day-to-day life, right? I mean, they are used as ingredients in many recipes. Here you can see many kidneys from a sheep. You can probably see many of these scenes at a local butcher. They are located in the humans in the posterior wall of the abdominal cavity. Each kidney in an adult weigh between 120 and 140 grams, and as many organs in the human body, there are two of them, because it's always nice to have redundancies in place. Humans can survive with only one kidney. So they are the link between the bloodstream and the urinary system. And as a matter of fact, what they do is to generate urine. They filter the blood and they generate the urine, which contains all the substances that need to be excreted from the body via the filtration system of the kidney. And by doing so, they contribute to the regulation of many homeostatic parameters: water, from the amount of water in the body, the amount of electrolytes in the body, and the balance of the pH, so the homeostatic long-term maintenance of the pH of 7.4 in body fluids, and last but not least, a key role in the mid and long-term regulation of blood pressure. So, as I already said, they are involved. Don't worry if I repeat things. Yeah, it's important to repeat things that are important. So, in repetition, there is learning. Yeah, repetita iuvant, said the Latins. Um, so they're involved in the homeostatic regulation of the volume of water in the body and in the concentration of inorganic ions in the body fluids. And they are mostly involved in the maintenance of the internal environment. So remember, yeah, when we talked about body fluids and homeostasis, yeah, the kidneys are, some of the main characters, yeah, some of the main protagonists in the maintenance of homeostasis, which is the maintenance of the internal environment. They're also involved in the removal of metabolic waste products. In general, anything that is hydrophilic tends to be easily excreted through the kidneys. They're also important, as endocrine glands. They produce erythropoietin, renin, vitamin D3, and prostaglandins. We will talk about some of these, especially in terms of renin as an agent for the control of blood pressure. And in a resting individual, the kidneys receive around 20 to 25% of the cardiac output. That is unimportant volume. So we're talking about 1.25 liters per minute. That is an important amount of fluid that goes through the kidneys in the unit of time. It is hard, if not borderline impossible, to make a machine that is capable to do what the kidneys do. Just in terms of hydraulic, I'm not talking about any fancy neural network, computer-based artificial intelligence. I'm talking about plumbing, yeah, having a pump, a filter that is able to filter for 80 years, 1.25 liters per minute, doing all the operations of filtering that the kidneys do. So they're impressive machines. And they ultimately result in the production of around 1.5 liters of urine per day. As a matter of fact, urine contains a certain amount of solid. So 50-70 grams of the 1.5 liters of urine contain solid deposits. The smell of the urine is affected by several factors, including substances contained in food, bacterial breakdown, and the consequences of the bacterial breakdown, which is ammonia, basically. The color of the urine, the golden yellow, yellowy color, actually comes from the urochrome pigments, which come from the breakdown of the porphyritic ring of the vitamin B12 and of the bile acids, which get broken down in urobilin. And the color and the smell, as a matter of fact, can help medical diagnosis. So once again, the primary function of the kidney is to maintain the homeostasis. Yeah? There are some of the main players in maintaining homeostasis in humans. So why are they so important? Huh? Here you can see a person which has to undergo dialysis, which is a life-saving procedure in case of kidney failure. Well, think about it, right? Anything that comes into your body that is not self needs to be excreted. Kidneys have a key role into excreting substances that are non-self, and usually sometimes these substances are are toxic, and also homeostasis, right? If the regulators like humans don't maintain their homeostasis, they just die. So they transform blood into urine. Yeah, they filter it and they generate urine. So as you can see, the plasma and the urine have obviously different composition, and the different composition reveals what is the function of the kidneys. So for example, in the plasma, you see a constant more or less constant concentration of sodium ions between 140 and 150 millimolar, while in the urine it can variate between 50 and 130, which means that the urine has a role in regulating the levels of sodium. Potassium is regularly higher in urine, and so in order to keep kaliemia, the kidney constantly has to excrete potassium. Same goes for calcium. Bicarbonate gets strictly reabsorbed because it has a very important role in the local regulation of the pH. The phosphate gets excreted. Chloride gets excreted with the same concentrations of sodium, because sodium and chloride always go together. Creatinine and urea, urea takes its name from urine because it's the most prevalent component of urine, come from the breakdown of proteins, and so they have very low levels in the plasma and high levels in the urine. No proteins in the urine, very, very important. As a matter of fact, the presence of protein in the urines, leading to foamy urines, can be a sign of pathology at the level of the kidneys. Glucose also is 0 in the urine, and of course the pH of the urine is always acidic because the urine has the role to keep the body fluids pH constant, and we are animals, so our metabolism is an acidic metabolism because it leads to the production of CO2 and water. And so in order to keep the pH stable, we need to excrete protons. Well, the osmolarity of urine depends on, if we have hypertonic body fluids or hypotonic body fluids. And so, if we have to save water, we will have a very diluted urine. Sorry, if we have to save water, we will have a very concentrated urine. If we have too much water, we will have a more diluted urine. So the kidney looks like a bean, pretty much, a large bean. In the hilus of the kidney, we will have the renal artery and the renal veins. The cortex, the cortical part of the kidney contains cortical nephrons, while juxtamedullary nephrons, which are literally the nephrons that are close to the medulla, are closer to the medulla. The nephrons are organized in renal pyramids made out of medullary tissue, and I'm talking about juxtamedullary nephrons. The renal column, on the other hand, is composed by cortical tissue. The pyramids converge into the calyxes. Minor calyxes coming from the pyramid, and major calyx, which is closer, it's more medial towards the hilus of the kidney, and the whole kidney is enclosed into connective tissue known as renal capsule. So this is pretty much what there is to say about the macroscopic structure of the kidney. The cortex contains around 1 million nephrons. The nephrons are the functional unit of the kidney. Nephrons, so are the functional units. So they filter blood and they control secretion and reabsorption of substances. The medulla contains the loop of Henle's and the collecting ducts. The renal pelvis or hilus contains the renal blood vessels and is the point of origin of the ureter. Both the major and the minor calyxes collect the urine coming from the nephrons, while the renal capsule, as I said, is the connective tissue which encloses the kidney. So going from the macrostructure to the microstructure, we will focus now on the nephron, of which you can see an overall description of the structure. Okay, so you see a glomerulus on which the afferent arterioles converge. You see a system of venous blood in the vasa recta surrounding the descending limb and the ascending limb and the loop of Henle. And then you see that the glomerulus converges into the proximal convoluted tubule, which then leads to the descending and limb and loop of Henle. Which then ascends in the ascending limb and in the distal convoluted tubule, which converges into the collecting duct. Don't worry if it's confusing, we're going to repeat these to the nausea, and then maybe by the end you're going to get it. See you in the next section.